The other night, while dealing with some insomnia, I started thinking about a certain question. I'm sure other people have considered this question before, but it was new to me. What if we took the basic idea of the Fibonacci sequence but multiplied the terms instead of adding them? Of course, if we start from 0, 0 times 1 is 0. This is what mathematicians call trivial, and I call boring. So let's start with 1 times 2. If we follow this, we get 1 times 2 is 2, 2 times 2 is 4, 2 times 4 is 8, 4 times 8 is 32, 32 times 8 is 256, and 32 times 256 is 8,192. We could keep going, but let's stop there for a minute. All of these numbers are powers of 2, and more specifically, 1 is 2 to the 0th, 2 is 2 to the 1st, 4 is 2 to the 2nd, 8 is 2 to the 3rd, 32 is 2 to the 5th, 256 is 2 to the 8th, and finally 8,192 is 2 to the 13th. In other words, the exponents are the Fibonacci sequence. This is not at all surprising, since that is how you multiply two numbers that are both exponents of a number. Add the exponents together. So this shouldn't be a surprise, but when I saw this result, I was pleasantly surprised to find the symmetry. We don't have to start with 1 and 2. We can start with other numbers, and they will follow the same pattern. Since we know what the exponent will be, we can find out the answer quickly enough. For example, if we start with 1 and 7, we know that the 11th term in the sequence will be 7 to the power of 144. This is a very large number, but we don't have to do the arithmetic to find out what it is since we know the pattern of exponents. We can also start with two different numbers, such as 2 and 3 in this example. Both of them will follow the same pattern, although the exponent of the first number will be one step behind the exponent of the second number. So if we start with 2 and 3, after 5 steps we have 2 to the 5th times 3 to the 8th, which is also a very large number. I know that this doesn't offer any earth-shaking mathematical concepts, and I'm sure many people have thought about this before, but I am always happy when I can find symmetry and pattern in mathematics.